Hello everyone, I am Chayashri J studying second year MSc in Computer Science, Manasa Gangotri, Mysore. Today I am going to present the topic on supervised learning, classification, regression and types of regression. First, let me know about what is machine learning. Machine learning is an application of artificial intelligence. Machine learning mainly focused on the development of computer programs that can access the data and it use it learn for themselves. Machine learning can be classified into four main algorithms: supervised learning, unsupervised learning, semi supervised learning, and reinforcement learning. First, let me know about supervised learning. Basically, supervised learning is a learning in which we teach or train the machine using data which is well labeled. That means some data is already tagged with correct answer. Example: regression, decision tree, KNN, etc. Advantages of supervised learning. Supervised learning allows collecting data and produce data output from previous experience. Supervised machine learning helps to solve various types of real world computation problems. Disadvantages of supervised learning. Classifying big data can be challenging. You need to select lots of good examples for each classes while you are training the classifier. Training for supervised learning needs lot of computation time, so it requires a lot of time. This is the examples for supervised learning and unsupervised learning. Supervised learning is classified into two categories of algorithms: classification and regression. First, let me know about classification. Classification is problem when the output variable is categories such as red or blue or disease and no disease. A classification model attempts to draw some conclusion from above observed values. Examples of classifications are: when filtering emails, spam or not spam, a given handwritten character, classify it as one of the known characters. And face recognition. This is the flow graph of the classification. Regression. Regression is a statistical method that helps us to analyze and understand the relationship between two or more variables of interest. The process that is adopted to perform regression analysis helps to understand which factors are important, which factors can be ignored, and how they are influencing each other. This is the flow graph of regression. In regression, there are 6 types: linear regression, logistic regression, rigid regression, lasso regression, polynomial regression, and Bayesian regression. First, let me know about linear regression. Linear regression algorithm shows a linear relationship between dependent as y and one or more independent as x variables, hence called as linear regression. Linear regression model provides a sloped straight line representing a relationship between the variables. Consider a below image. The linear regression equation without error is y is equals to bx plus a, and this is the flow graph of linear regression. There are two types of linear regression: simple linear regression and multiple linear regression. Simple linear regression: if a single dependent variable is used to predict the value of a numerical dependent variable, then such a linear regression algorithm is called simple linear regression. Simple linear regression can be solved using the equation y is equals to a0 plus a1x plus epsilon. a1, it is the intercept of the regression line. a1, it is the slope if the regression line, which tells whether the line is increasing or decreasing. Epsilon is the error term. This is the flow graph of simple linear regression. Multiple linear regression: more than one independent variable is used to predict the value of a numerical dependent variable, then such a linear regression algorithm is called as multiple linear regression. And y is equals to mx plus c, where y is the output of the model, which is also called response variable. X is the independent variable, which is also called explanatory variable, where c denotes the intercept. And this is the flow graph of multiple linear regression. Logistic regression. Logistic regression is basically based on the supervised classification algorithm. In classification problem, the target variable y can take only a discrete value for a given set of features x. Logistic regression model is the data using sigmoid function. Log of p divided by 1 minus p is the link function. Logarithmic transformation on the outcome variable allow us to model a non-linear association in a linear way. This equation is used in logistic regression. Here, p divided by 1 minus p is odd ratio. This is the flow graph of logistic regression. Rigid regression. Rigid regression is a model tuning method that is used to analyze any data suffers from multicollinearity. When the issue of multicollinearity occurs, least squares are unbiased and variance are large. This results in predicted value to be far away from the actual values. This is the flow graph of rigid regression. Lasso regression. The lasso stands for least absolute shrinking and selection operation. Lasso regression is a regularization technique. It is used over regression methods for more accurate prediction. This model uses shrinkage. Shrinkage is whether the data values are shrunk towards a central point as the mean. This is the flow graph of lasso regression and the formula which is used in lasso regression. Polynomial regression. Polynomial regression is a regression algorithm that models the relationship between dependent and independent variable as nth degree polynomial. The polynomial regression equation is given below. The general form is y is equals to b naught beta naught plus beta 1 xj plus beta 2 xj square plus etc. plus beta p xj p plus epsilon, where beta naught is equals to population regression constant, beta I is population regression coefficient for variables of xj, where j is 1, 2, 3, etc. k. P is equals to order of the polynomial, epsilon naught is model error. If p is equals to 2, the model is a quadratic model. Y is equals to beta naught plus beta 1 xj plus beta 2 xj square plus epsilon. And this is the flow graph of polynomial regression. Bayesian regression. Bayesian regression allows a fairly natural mechanism to survive insufficient data or poor distributed data. It allows you to put prior on the coefficient and on the noise so that in the absence of the data, the priors can take over. And the Bayesian equation is y is equals to beta naught plus beta 1 into x1 plus beta 2 into x2 plus epsilon. And this is the flow graph of Bayesian regression. Thank you.